Hello guys, and welcome to your 7th STL2 tutorial. In this tutorial, we will be going over simple collision detection. Alright, for this tutorial, you're going to need another ball sprite. You can just recolor the first one and save it with a new file name if you'd like. Or you can just use the exact same image and just not make a second one and just use that one. Do what you'd like. Alright. So for this tutorial we're going to need another ball, and that's pretty much it for the resources. Alright, so let's do that now. So just like the original ball, we have to color key it and get the surface and make a texture of it. Alright, so SDR versus your surface. And now we have to color key that. Alright, so let's make this surface. Let's just name this ball 2. And let's load the image. Data / ball 2 .bmp. Now let's color key it. Set color key as ball 2 SDL true SDL map RGB S ball 2 format 0 1 1 for cyan. Alright, now let's make the texture. T-ball 2 STL create texture for surface. Render, and then finally the surface. Alright, fix all typing spelling errors. And finally we need our rect. So SDL rect. And I'm going to show you guys a different way to make these. Let's name it R ball 2. Alright, so you can also make these like this. So you can do it like that and define them this way. Or you can also make it a pointer and define it that way. So it doesn't matter which way you do it, but I prefer defining it like this. Alright, so let's set the X to, let's set it to 0 this time. And let's set the Y to half the width of the screen. So that would equal 600 by 480, so that's half of the height. So that is 240. Alright. And now we need to set the width and height. So that equals S ball 2 dash width. No, height. And R ball 2 dot width equals S ball 2 dot width. Alright, now that's set up, and let's render this. So STL render copy, renderer, T ball 2, no, and address of R ball 2. So to run this. And check for errors, set color key, spelling error, and now let's run this. No errors. And there you go. So now we see the blue ball is right there. Alright, so let's make this blue ball move left. Alright, so let's put this right here. No, I have a better idea. We'll just keep this logic, and we will add the same for the blue ball, but it will go in the opposite direction. So if r ball dot x plus r ball dot width is less than the window height, the window width, which is 640, then we're going to continue to move it. So r ball 2 dot x plus equals 250. Make sure there's a 2 there. Alright. Else, then we're going to stop motion. Else r ball 2 dot x minus equals 50. And there you go. It's supposed to run this. Check for errors. Capital B. Alright. Supposed to run, no errors. Now you can see the ball is all the way out from this side to the left side. To the right side. Alright. Let's try it again so you can see that again. Alright, so let's make it a little slower. So plus equals 1. That should be a little better. And now, they move the same rate of speed. Cool. Alright guys, so now let's get the collision detection. Alright, so let's make these two balls collide with each other and start moving. Alright, so let's do that here. So if r ball dot x is greater than r ball 2 dot x, so that means that the x coordinate of the first ball is inside or past the second ball's x. Alright. So now, if that is true, we need to test if r ball dot x is less than or equal to r ball 2 dot x plus r ball 2 dot width. Alright, so this means if the x coordinate of the first ball is within the second ball's, like, within that area for the width. So basically, zoom this in. So if the ball, so ball 1 is within this area, like this entire shape, like within this area for the x-axis, then that would be true. Alright. So let's give this figure some more room. Alright. Here now we have a nice little diagram. Alright, so if the figure, or the first ball, is within this area, so right in this area. It can be like anywhere on the x-axis right now. So that would count. Alright. Now we gotta test the y-axis. So if r ball dot y is greater than r ball 2 dot y. So that means it is down there. So now it has to be in this area. Notice how the area that it can be in is getting smaller. Now if that is true, then we're going to test if r ball dot y is less than or equal to r ball 2 dot y plus r ball 2 dot h. So now it has, if it is in this area, so within the area of the ball, then that would be a collision. Yes, that would be a collision. So this means there was a collision. Alright, so if there was a collision, then that means we don't want to move the ball anymore. Alright, so let's actually take all of this code. We're going to move it from here, and we're going to put it in here. And we'll put an else statement. Alright, so this is here for if the collisions, like it wasn't a collision. So that means we're going to run all this movement stuff, because that means we're going to be able to move the ball. Alright, so let's just indent this right here. Alright. So if there was a collision, then we're not going to do anything. Alright. So now we can build and run this. Fix all spelling errors. One right there. Build and run it, and let's look for errors. Alright. So let's actually undo that. And so if there is a collision, we can just move them back. So r ball 2 dot y minus equals 1, and r ball 1 dot r ball y minus equals 1. This will move them back to the position they were before the collision, making it not noticeable that they moved at all. So it will appear that they just stopped. Fix all the errors. And there you go. When they collide, they stop moving. Alright. Thank you guys for watching, and that's it for this topic. I'll see you guys in the next tutorial.